So you have a FieldFox now, and you have a signal radiated from P25 repeater base station, quite far away, and you're seeing some signal here. So what can you measure using a FieldFox? So one of it is, of course, the channel power, and here is where I'm going to show you step by step how to do it. Welcome back to my channel, and this is where I'm going to show you step by step on how to find the signal and how to do the channel measurements, and I'm going to walk around the office building just to show you what type of result that we can get from the channel scanner. Mainly, FieldFox is measuring the physical layer information such as the frequency and also the amplitude of that particular signal. So I'm going to reset the hold mode. So I'm going to show you step by step on how to set up the FieldFox before we go out for a walk. So as you can see, the signal is 420.475 megahertz. So I'm going to preset the mode, and you can actually see how I'm going to do it step by step. Preset. And if you're not in spectrum mode, just go to mode, spectrum analyzer. Let's set the center frequency to 420.475 megahertz. And let's lower down the frequency span to, let's say, 1 megahertz, because we know that the signal is not too wide. So we have some signal activities here. As you can see that some multiple channels happening here. Even with that, the signal is not too obvious. So what we can do here is to turn on the preamp. So if you have the options preamp, let's go to scale amplitude, turn on the preamp, then we turn on the RF attenuation. So right now it's at 0 dB attenuations, so we can see a better signal to noise ratio. Right, let's turn on the marker right now. So as you can see, it's 420.475 megahertz. This is what we want to check. Of course, there are multiple channels here. We can add that into our channel scanner. So the other one is 420.175, and let's turn on the third one. I think it's 420.0265. Let's see, somewhere here. Yeah, 420.0625. Yeah, we have another signal there. Let's start with this tree, and one of the things that I would normally turn on for multiple marker is, let's go to marker, and let's go to more and turn on the marker table. You can see that the result straight away. So the next thing I want to do, we identify that point of interest, and we can actually turn on the marker functions. For example, we want to do a quick channel measurements, channel power measurements. Just turn on the marker functions to band power, and then our signal is not that wide. So let's zoom into one for this one. So it's definitely more than analysis bandwidth right now. Let's go to marker again. So this is where you're going to change the analysis bandwidth. So we click on that, and we go to span auto. So we increase that to roughly that 3 dB. Yeah. So it's about 9 kilohertz. So this is the channel power of that APCO25 signal here. So marker 1, you're looking at 76 dBm. So if you turn that off, it's just a peak 1 point measurements. So you're going to see that similar things for channel scanner. So let's increase the span by a bit. Yeah, the marker will move as according to your signal span. Let's do this. Let's turn it off. Let's turn on again. So we start from 1 point, and roughly that. Right, so we turn off the marker tree for now because the activity is up and down there. Just to recap, so if you have a preamp, turn on the preamp, reduce down the attenuations if it is very far from you, and from there you can get a better signal to noise ratio. So the next thing I want to do is let's go to a channel scanner before we bring it out for a walk. So let's say we have P25, 38, let's go there, P25, channel 2, something like that. So you can change the name. So center frequency, this is where we can change. So currently we have 1 point and 40K, it's about there. We can change it to 9K just to standardize everything. The other one is 420.475 Mac, and also we change it to 9K. So what you really want to do is to make sure that all these signals are correct, and then 2625 megahertz to 9 kilohertz. So what I did was I did the custom list and make sure that the points are at the points of interest: 420, 475, 420, 2625. Just to check that, we can either go back to spectrum analyzer mode. Let's say our marker here, marker 2, it's supposed to be at 420 by 265. Yeah, somewhere there. So we have signal there. Confirm. Or you can use the channel scanner and change that display type to channel power. So at 420.625, this is our channel scanner. This is the value right now. Let's change the reference level so that we can see much better. And then this way you can turn on the preamp. So I didn't preset this, I did something before this. So basically what you need to do is to always make sure the preamp is on, because from mode to mode it doesn't link together. So in spectrum mode, you turn on the preamp, doesn't mean that channel scanner preamp is on. So we go to scale amplitude, go to more, turn on the preamp, then we turn down RF attenuator. So the second one we want to do is this one, and change it to cancel it. Say we change to ID. How do I change the ID? So how do you change the channel? Currently it's at channel 1. So you go to frequency, then this way you can change to channel 2. So 420.5, and then the third one is 420.265. So you can see that there's some activities there, so you're good to go. Let's go back to measure. So let's change the bar chart. So after this, we're going out and we're going to do a data logging. So how do we do the data logging? Is over here. So before that, you can see that we can actually save the list for future use. If you want to, you just click on that and save list. As for example, we can type in today's date, APCO list. So once you've done that, you can recall anytime you need to. So what I'll normally do, just for sanity check, is that I will add on one more channel, a control channel. Means that it's channels that shouldn't have any signal, just to make sure that I'm measuring something. A channel without any signal should be quite low, but because the integrated bandwidth is quite wide, let's change that to similar, 9 kilohertz. So this just to make sure that your measurements is way above that noise floor, and you are sure that there are some signal activities, you are measuring something correct above the noise floor. So after this, we can do a data logging. So do a record setting. So interval, I'm going to do a distance about 10 meters. I'm going to walk around the building so that if I stop at one point, it won't accumulate like a hive of bees when we try to export it to KML file. So it depends on your situation. Sometimes you want a time, sometimes you want distance. So for this case, we want to set it to distance at every 10 meter. And after this, I'm going out for a record. And then we can come back and revisit the KML file, how it looks like. So currently I'm outside right now. I'm going to click record and I'm going to walk through the building.
So you would see that so you start recording. As you can see the number here, you increase every time I hit a 10-meter mark. So it looks like there are some signals coming up that the base station might be quite close. So right now we have about 17 traces. So one thing I should have done is to change the display. So let's go to, oh, we can't change it right now, but I'm going to show you how you can change the display to be high contrast so that you can see it out in the, so you can see it outdoor clearly.
So now I'm back to the office, so we can save the record. So how do we want to do it is by clicking this record save recall and then save log file. So as you can see right now, the file type that I've chosen is KML. From here you can choose CSV or KML. Select that and click enter. Let's say we start with CSV file and then we save log file. You can type in the file name for it and make sure that the file type is what you want, and then you can click done. And in the event where you want both files to be saved, you can do it the same way. Just go to KML. So in the event where you have saved a CSV and then you did all the post-processing that you need, but you forgot to save KML file, it's not the end of the world. We can do that again on the FieldFox. So what you need to do is to recall the log file. It can be KML or CSV file. So let's say this is the one that we saved just now, CSV file, recall it, and then we change the file type to KML. Then from there, same thing, you can just save the log file, change the file name, and make sure, oh, this is still CSV. So what I need to do is this, CSV KML, enter, file type KML, save the log file, make sure the file type is what you want, change the file name, click done. So it's as simple as that. So with that in mind, I'm going to show you how it looks like in the Google Earth. So this is a KML file that we can see here. Once you click on KML, if you have a Google Earth install, and this is how it looks like. So I'm going to do this. Let's turn up to and the data, you can just click on it, and if you remember all the points that we try to measure as we walk around the building, this is the data format, how it looks like. And of course you can play around with this part where you can just scroll around and then just move it back there
display, such as this. Okay, if you want lesser, then just move it back there. Let's try. So you can see that I was walking about around the building. Let's move it back here. So this is how a KML file looks like, and I'm going to show you how an Excel file looks like, the CSV file. This is where all the information are saved. So we have the longitude, latitude, altitude, and then we have the frequency and the band, the channel power measurements, and so it's horizontal. And this channel 1, channel 2, channel 3, channel 4. So with that, it's able to convert to KML file. Again, it's just software. So I hope this helped.
One more thing I forgot to show in the video is how it looks like when we change the color to outdoor setting, which I should have done it before doing the video. But anyway, just for your information, this is how it looks like. Let's go to System, Display, and we change the display color. So outdoor sun. So this is how it looks like. And it will really help when you go out walking around under the sun. So with a high contrast such as this, you are able to see what's going on instead of those colorful dim black background. You might be able to change that spectrum. Let's see here. So we can actually change that to something lower, but you can change the spectrum of it. Can't really change the color, temperature of it. Even though it says blue and red limit, it's still purplish color here. Right, I'll let you go. Thanks for watching.